Logical? In fact, it's logical. Some of these other past things may not be so logical.
That's not true.
Okay. All right, now, what's an abdominal synthesis? You take a needle and syringe, right? And you're very, you got to be very aseptic about it, right? Because if you just stick a needle and syringe in there without being aseptic, cause more problems. Why are we doing it? This animal probably detected fluid in the abdominal cavity of this animal. And could that fluid tell us what might be going on? All right, now normal abdominal fluid usually has a specific gravity of less than 1.0, total protein of less than 3 grams per deciliter, a cell count less than 1,000 per microliter. Okay? We did this fluid right here, and it should be clear. What about this fluid? Cloudy. Okay, so what can make things cloudy? Protein. Also, cells. Other kinds of things. If you, I can go into it, but usually it could be, you got different classifications of fluid. Normal is going to be a specific gravity less than 1 because it's low protein. It usually has a total protein content of less than 3. And usually for pure transportation less than 1 gram. Okay? And cell count usually less than 1,000, 800 to 1,000. Large animals less than 460. Okay, so if you look at this, we already know something's wrong, right? It's cloudy. What's its specific gravity? That's what, 1.0? So does that tell you the proteins, cells and stuff? All right. What about the total protein? Very high, much higher than the 3 cut off in it. And so what can cause protein being in this fluid? Could they be inflammatory protein? Could the cells that are in there be breaking down also? Cells have protein in them? And this instrument's not going to tell you, well, we're not going to count this protein because it came from that lice cell. Okay, so I'll give you a total thing. Now, what about our cell count? A little high, isn't it? 9,000, a little bit bigger than 1,000, isn't it? So if we look at this, and this is the sphere, what are the cells in there? Neutrophils. Neutrophils, they have some macrophages in here. What do we have in some of these neutrophils? Bacteria. Now you can't say gram-positive bacteria because this is a right stain. All bacteria stain blue. What would you have to do to find out what kind of bacteria it was? It's a gram stain at all. Okay. So looking at this, how would you interpret this fluid? Is it a transudate means that it's just pure transudate means you got low proteins, the fluid's coming out. The vessel lost down cardiac pressure. Modified transudate, cell count's low, but the protein's very high. Transudate will then go, pardon me, can go into an exudate. Exudates can be neoplastic, inflammatory, and hemorrhagic. What do you think this one is? So this is an inflammatory exudate. Do I go along with that? A septic inflammatory exudate? So could that tell you that that gut wall is really compromised? What's inside the gut liver normally? Bacteria. They come up to this compromised wall. So let's go on vacation. We're going to go out here and sell them cabin. Is that where you want to go? Are they going to be particular about not buying any other organs or anything? So that's interpretation. Inflammatory exudates can be a septic inflammatory exudate, a non-septic inflammatory exudate, a neoplastic exudate, or a hemorrhagic exudate. Okay? You all get that next semester. But y'all know it already now. We can skip it next year, right? Next semester, right?
Actually, they'll get it in this semester.
Oh, yeah.
Inflammation.
Yeah. So what do we know so far? Do we have probably an inflammatory process going on that may be aggravating tissues and stuff like that?
Yes.
Does that explain the CBC results?
Yes.
Yes, ma'am.
I have just one question. Is there any PowerPoint or for us to see the values for the CBC?
And you put a path notes next to that.
Now, that brings up a very important point. The new curriculum will have a shift in when clinical path is taught. It will actually be taught in the first semester along with general math. Now, the labs will be very similar to what you're doing now, okay? Where you incorporate all of this stuff together. Instead of having something way over here and then something way over there, and then you trying to put it together, which you usually don't do. So that's the idea here. And that's why we're doing it this way. This is the first time we've actually had both components present in the lab to this degree, okay? And that is so you can put things together. That's the whole idea. So you can do that.
Now you see what I was telling y'all yesterday when I had to stay up all night and everything, put this stuff together. Yes, ma'am.
Can you explain, I guess briefly, the connection between the inflammatory, like the inflammation and the liver problems?
Well, if you've got inflammation in the abdominal cavity, is the liver in the abdominal cavity?
Yeah.
And can the blood pick up the toxins and also the bacteria from there? And where can it go? Where's a lot of it going to go first if it's in the abdominal cavity? What's the main vessel that drains the abdominal cavity? The portal vein. What's the first stop? The liver. Okay? And that's one reason that a lot of people are crazy about the liver. That's why I did my graduate work and everything else, because it's so important. Okay? And if you look at it, in other words, it doesn't mean there's not inflammatory processes anywhere else. But the liver is going to be very susceptible to that because it's going to get exposure very quickly. Okay? Can I answer your question?
Yeah.
Okay, now let me ask you a question. You think there's something wrong with the gut, right? Well, what would be some methods you could find out to see what's going on with the gut? What about laparoscopy? Did you go in and look at it? But what's going to be a less invasive technique? Radiograph. Now, will radiographs always show you what's going on? No. This one does.
Okay. So how many of you actually went to the website and looked at it? What did it tell you this was? Intussusception. And it points it out right in that area. See that line? Right there. This part of the gut has telescopes inside the other one. And where's the rest of the gut going? All down back here. So what part of the gut is probably involved here? And from what you should be understanding as far as malposition and cause and nature of disease, remember we talked about intussusception? Remember that? When one part of the gut goes inside the other one, first thing that happens is you block blood supply. Second thing is you stop the gut from moving. And when you get that telescope and you get a little line like that that you can see on a radiograph. So that's what that is showing you. And what parts of the gut are more susceptible to that kind of thing happening? One part, one inside the other.
One is smaller than the other.
When you have disparity in size, when you have a smaller part and a larger part that are close together, the smaller part can go inside the larger part. So looking at that and looking at the colon coming on out on this animal, what do you think this probably happened? Ileocecal colon. In that area, ileocecal valve, you have a smaller part, you have a bigger part down here. So what probably went inside what? The ileum probably went inside the colon. So that's what you have here. And that's what I actually put on the blackboard back there in drawing that little diagram. That shows the abdominal wall and that area of the gut that has telescopes inside itself.
If you cut off the blood supply, where do you use the tissue? kill it, right? So how y'all doing on your interpretation so far? Well, we'll let you pass a little bit since this is the first time, but wait till the next lane.
Okay. Now let's get a slide. This is where the real stuff is. Okay? Pull out the slide. Go ahead. On the microphone.
You might as well just share it.
That thing you have on the desk is on the microscope.
We got that. It's called a microscope. Come on. Cheers.
So, is there anybody that does not actually have this section? CS5? CS just stands for class set. That's all that. And then we number the things that we selected. So, anybody not have that? Where's your microscope?
Everybody got a CS5? More up here.
There's some more.
I don't know if
They
it's
don't
a
actually
name
have
issue
that.
and they'll name the microscopic changes you can discern.
Now,
Oh, I just don't like that stuff.
if you're looking at a slide, what's the first thing you really should do? Take it on the microscope and go to the highest leg, right?
No.
No, what should you do?
That's what we did.
Take the slide.
Now, if anybody doesn't have both slides, there's plenty up here that have both slides in them.
Yeah.
No, we
Yeah.
found. We found it. Oh my God. Always hold it like this.
What's the first thing you should do when you're looking at a slide? Stick it on a microscope right away and put it on the highest magnification you can find. No. What should you do? Hold it up and look at it and see what you got. If you have something that's circular, what does that probably mean you have? A tubular organ. What tubular organs do you know? Blood vessels? The GI tract? Okay? So that gives you an idea about what you might be looking at by doing that. And you look at it at low magnification. How many of you have heard the expression, I can't see the forest for the trees?
No.
So if you go to real high magnification, you blow up everything so that you can't really tell all of the interrelationships between the various things that are there. So that's why you look at it at low mag first and try to figure out what's going on. Now, most of you hate microscopes because it requires you to do quite a bit of putting things together. But that's the whole idea behind this, so that you can understand really at the tissue level what's going on, because all of these things that you would see clinically in this dog and these there. That's the whole idea. Okay. Now, for those of you who say, oh, well, I'm not going to be looking at a microscope when I go to practice. Okay. And after you there about 2 days, here comes the text saying, Doc, I got this problem here, and you don't even know how to turn the thing on. Because you never touched one. I don't want to look at it. I don't want to do that. Turn the microscope on and look. Okay?
It's always been my feeling that until they make a computer that I can stick a glass slide in and it'll tell me what's on there, you've got to know how to use a microscope. Okay?
So, what do you see?
Still got me.
What do you see now? Do you see this tubular structure?
Yes.
Actually, you see a tube inside a tube.
Bam.
And what is that a definition of? Intussusception.
I don't know where he saw a tube inside a tube. Like, I'm looking right now. A tube inside of a tube.
Everybody does have this slide
Right before he said that, Lou was like, does it look to you like there's a tube inside of a tube? And then it was like, you didn't capture it? Yes, I did. How did you see the tube inside the tube? Because it looks like a, like go to the lowest magnification, it looks like a circle within a circle.
Go to the highest one?
Now go to the lowest.
This is low.
No, go to the lowest.
Doesn't that look like the picture in the book you see when you're talking about? The tube inside a tube and stuff? Where do you think they got the picture from? The microscope.
You can do it.
See, I don't get it. I don't see.
That's an outcome.
I don't see the tube
That's what we
inside
saw.
the tube.
I think that's what we were all.
I don't see what you guys see. Yeah.
Okay, you should be able to see something like this. And what part of the intestine is it? Small intestine, large intestine, what is it? Small. How do you know that? Villi, okay. So you took histology for a reason. All right. Now, that is pretty normal. Now what about that? Yes, we cross it here. That look like that those normal villi? What's it look like? When you were in class this morning, and we were talking about irreversible cell injury, cell death, and we showed you an egg that had normal albumin in it, nice clear stuff.
The microphone over there, close.
When we showed you the egg, the broken egg, two broken eggs, one of them had nice clear albumin, and the other one had some cloudy looking stuff. Right along there, what's that as far as the mucosa is concerned? Would you call that coagulation? A coagulative necrosis? If you wouldn't, you're wrong. That is coagulative necrosis. Remember looking at the normal? Yep. Can I point out what?
There's the arrow right there. No, the arrow is pointing to where he's talking about. That's the surface. That's the
Look at that.
surface of the
Okay.
mucosal line.
That's the line. Look at that. And compare that to that. Oh, see? Now, why in a lot of the cases that's not lined up completely the way it should be is during the section in the outer part, which is the most normal part, got pulled away a little bit, so it's not in close opposition to the other part. But that's what it should look like. Now there you can see individual cells. On the other one, you can't really see cell outlines very well. Now I know once you didn't read what you're supposed to see with coagulative necrosis. But you see the loss of cell outlines and this homogeneous look to the cytoplasm and lack of the nuclei. Now you see all of that stuff I just said? Lack of the nuclear outline, lack of nuclei, lack of cell outlines. Okay. Now what about the blood vessels? Are they normal? Are they normal? No. What's wrong with them? They're full of blood. What did I tell you happened as far as the GI tract is concerned, and well, anything else? If I put a tourniquet on my arm, what am I going to block?
Blood flow.
Which ones? I'm going to still pump a little blood in there because the arteries have a much thicker wall and they can still push blood down through the arteries. But can the blood return? The veins have thinner walls, so they don't. Most of what you're looking at are just dilated veins. Now, what is that doing as far as oxygenation of the tissue? Is markedly decreasing it. So what you're looking at is necrotic gut inside, because the mesentery was trapped as this gut went inside. That blocked the venous return, and you get all of these engorged vessels like that. That's what you got. That's what you're looking at.
Why is it more pronounced toward the lumen versus the basal membrane? Where's going to be the least blood supply? Where the lumen is the upper layer, because the blood has to diffuse through this way, right? You're getting a little bit of supply to the basal layers down there, but they're taking it all, right? And that's why you can see